This is a short product demonstration on the proper testing procedures of our plugs, rope and hose, and relief valve. First thing you want to do is inspect the surface of the plug and the rope and the hose and the gauge. Start with the gauge. Make sure you've got a gauge that's starting at 0. It's got a plastic cover. It's tight, it's not scratched up, so you can read the gauge properly. Make sure you've got the foam cover around the gauge to protect it. And then go down to your valves. Make sure the ball valve works properly. And be sure the Schrader valve has the valve inside of it, and someone hasn't taken it out or damaged it or bent it. Be sure the Schrader valve's in good shape and that the needle is in place, it's not bent or missing. Make sure the valve is operational, that it turns and stops, the handle's tight. Next you want to check your hose where it comes into the block here. Continue on down looking for cuts, scrapes, separations, and come up to the plug. At the front of the plug we want to see the inflation hose hard lined into the front of the plug. It offers us few connections, which reduces the possibility of leaks. Also, these should be tested as a unit with the hose, inflation, and the plug. Make sure the relief valve is in place. We're going to check it in a minute. Make sure your D-ring is in place, the pin, and the eye bolt isn't all bent up. And repeat this procedure for the back of the plug. Now we're going to look at the surface of the plug. You want to rotate it all the way around, inspect for obvious deep cuts, rips, tears. Minor surface cuts or abrasions are normal, but anything that's very deep, we want to see it. As a note, 75 to 80% of the plugs that are sent to us are repairable, and the average repair cost is under $200. So if you damage a plug from a sharp object or something cutting it, there's a good chance it can be repaired. So notify us, send it in, and we can probably save it for you. If you have any questions about surface abrasions or the safety of the plug, call us, send us the plug, we want to see it. We will not charge you for repair if the repair will not hold, and we will only repair the plug if it will come back up to 95% of its original specifications. You have nothing to lose by sending in a damaged plug. Okay, what we have here is a multi-size plug. This plug fits pipe 8 to 12 inches in diameter. Notice that the plug stretches to go to the larger pipe size. Now it's worth noting that when a plug stretches, it gets thinner. It's got to come from somewhere, and this is true with any inflatable rubber plug. Let's say the wall thickness is 1/4 of an inch when it's in 8-inch pipe. It gets to about 1/8 of an inch in 12-inch pipe when it goes to the higher side. So you want to be sure that any cuts or abrasions are not very deep, because the actual wall of the plug comes to about half the size in the larger pipe diameter. Next, we want to fully insert the plug into a short piece of pipe. Make sure that the plug is fully inserted into the pipe. It's not sticking out the back, not sticking out the front. The next thing we want to do is put a small amount of air pressure in the plug. We're going to bring it up to about 10 pounds while the plug is fully inserted into a piece of pipe. Bring the plug up to 10 pounds of air pressure, no more, to check for leaks. And the way we check for leaks is using just a little spray bottle of soap and water. We spray down the fitting and check for bubbles. And repeat this procedure for the back side of the plug. Check all the little fittings and any threaded fitting for leaks, which we evidenced by bubbles.
Now we're going to test the safety relief valve. First thing you do is you take it out of the plug, and what we're going to do here is we're going to test it up to the pressure that it's rated at. So for a 35 psi max plug, you're going to test the safety relief valve to 35 psi to make sure it's not defective. You have the air supply coming in, then a ball valve to regulate the air, and then you have an actual regulator which adjusts the pressure on the gauge, which is adjusting the pressure that's going to the safety relief valve. You have the safety relief valve on the opposite side connected with this coupling here, and the air passes through here to a certain psi here over to this. Whenever you get up to pressure, it should blow off or it should hold, depending on what it's rated at. Now we're going to test this one. You always start with your regulator down pretty low. Open your air valve. Bring the pressure up. You don't have to bring it up fast. Up to the pressure that it's rated at, which in this case is 35 psi. Then you take a soap and water bottle and you spray the end of the safety relief valve. If it was defective, it would leak at the pressure that it was rated at. In this case, it's good, but you always want to check and see where it starts to leak at. In this case, 40 psi. That's perfect. Then you want to bring it back down, bring it back up to its 35 psi, test it again. Perfect. And your test is over.
To determine the pressure at which this valve should blow off at, refer to the front of the plug. The inflation pressure is stamped on the front of our plugs. In this case, it was 35 psi. This valve should be bubble tight so that when you apply soap and water to the valve, there are no bubbles at 35 psi. The valve should blow off between 36 psi and 40 psi. In other words, approximately 5 psi over the recommended inflation pressure of the plug. At no time should this valve leak or have bubbles at less than the inflation pressure of the plug, and it should also be discarded if it goes to more than 5 psi over the inflation rating of the plug. These valves are not adjustable. It's a pass-fail test. This is our 400 series plug. We're going to show you how to do some basic tests to this. This is very simple, and what to do if you get rocks stuck underneath the bladder. So first you want to check the bladder for any cuts, scrapes, or abrasions. If there's any problems, of course you want to send the plug back to us, and we can replace this entire bladder and keep the aluminum core. These plugs have a removable lid. We can change the flow-through size easily. By removing the lid, it exposes the aluminum core, but most importantly for this test, the inflation hose on the inside of the plug. We'll attach the air supply with a ball valve, and then we will inflate the plug, checking for leaks. And where there's bubbles, we have leaks. Continue the test all the way down inside on the inflation hose deep inside the plug there, checking for bubbles. If there are no bubbles, no leaks, we can proceed to the next step. Now we're going to inflate this bladder, watch it roll up from the bottom side so that we can check for rocks and other sharp objects and debris that could be trapped between the bladder and the aluminum core. Notice that the bottom of the plug has rolled away from the aluminum, and up in this area is where you can find rocks and other sharp debris that have become trapped in here. As this plug was in the line on this side and they deflated it, it'll roll over rocks and other debris that are caught in here. So you want to inflate the plug, pull this up from the bottom, pick out any rocks or sharp objects, that could cause a plug to deflate and fail in the future.
We build plugs that work every day. Our units have not only withstood the test of time, but have set a benchmark for the future. Which reminds me, we have a fully staffed friendly service department. We service what we sell. So there isn't much in this industry we can't handle. We invite you to visit our facility in Lodi, California. Let us walk you through our plant and talk with the most experienced group of foremen, machinists, craftsmen, and technicians in the business. We know you'll agree. Plug-It is the #1 custom-built pipe and sewer plug manufacturer in the world. So remember,